Good morning, ma'am. My name is K. Pranavi and my roll number is 234G1A0488 and I'm from ECEB section. And my topic in probability and complex variables is joint characteristic function question. Let's see what is the question. Two random variables x and y has joint function by x comma y omega 1 comma omega 2 of exponential of minus 2 omega 1 square minus 8 omega 2 whole square, and show that x and y are zero mean random variables and or x and y correlated. So before going into the answer, let's see what is the joint characteristic function. The joint characteristic function of two random variables and y is defined as phi x comma y t1 comma t2, that is expectation of e of exponential of I t1 x plus t2 x t2y. That is, e denotes the expected value and t1 comma t2 are the parameters in the complex plane. This function encapsulates the joint distribution information of random variables. The joint characteristic function is of random variables x comma y is defined as phi x comma y omega 1 omega 2 is equals to expectation of e power j omega 1 x plus j omega 2 y. Now integration of minus infinity to infinity, integration in minus infinity to infinity e power j omega 1 x plus j omega 2 y function f comma y of x comma y dx dy, where omega 1 and omega 2 are real numbers. By setting omega 1 equals to 0 or omega equals to 0, we obtain the marginal characteristic function. So let's see the answer for the given question. Though the given characteristic function is that phi xy of omega 1 comma omega 2 is equals to exponential of minus 2 omega 1 whole square minus 3 omega 2 square. So how do we find the joint moments? We all know that joint moment formula is mnk is equals to minus j of phi xy of omega 1 comma omega 2 by d omega 1 power n omega 2 power k, and where the omega 1 omega 2 values are 0. So the first order moments are m10 equals to expectation of x, that is minus j into d, that is differentiation of phi xy of omega 1 comma omega 2 by dou omega, that is when omega 1 omega 2 are 0. And next first order function is m10, that is minus j dou exponential of what is the given function. Characteristic function is minus 2 omega 1 square minus 8 omega 2 square by d omega 1, where omega 1 omega 2 equals to 0. So by differentiating the given characteristic function, we'll get the value, that is minus j of minus 4 omega 1 exponential of minus 2 omega 1 whole square, where omega 1 equals to omega 2 equals to 0. And then we'll get the 0. Why? And m01, it is also the first moment. Expectation of I equals to minus j into differentiation of pi xy of omega 1 comma omega 2 by dou omega when omega 1 omega 2 equals to 0. Then minus j dou exponential of minus 2 omega 1 square minus 8 omega 2 square by dou omega 2, where omega 1 equals to omega 2 equals to 0. Then by differentiating the exponent given characteristic function, will get minus j into minus 16 omega 2 into exponential of 2 omega 1 square minus 8 omega 2 square, where omega 1 omega 2 equals to 0. Then the expectation of y becomes 0. Here the mean value of y is also 0 and x is also 0. So let's see the first question, that is correlation of x and y. So we found the what is the mean of x and y. Now we are going to find if they both the random variables are correlated or not. That the correlation formula is rxy equals to expectation of x into expectation of y. If this, so here the expectation of xy equals to expectation of xy equals to M11. That is, now we have to find out the M11 value. So M11 is given as minus j whole square d square omega 5 xy of j omega 1 comma omega 2 by omega 1 comma omega 2, where omega 1 and omega 2 are 0. Then by applying the characteristic function in the pi xy of omega 1 comma omega 2, will get minus d square exponential of minus 2 omega 1 square minus 8 omega 2 square by dou omega 1 dou omega 2, where omega 1 omega 2 equals to 0. Now by differentiating the given characteristic function, will get minus 4 omega 1 into minus 16 omega 2 into exponential of minus 2 omega 1 square minus 8 omega 2 square, where omega 1 omega 2 equals to 0. By by uh, by writing omega 1 omega 2 equals to 0 in our given equation, we'll get the m11 equals to 0, where expectation of xy equals to 0. Now we know that exy equals to, if exy equals to e of x into e of y equals to e of xy, then it is given that the both two random variables are uncorrelated. So the conclusion from this presentation is that we solved the joint characteristic function question, and the above slides will briefly give you the idea to solve the similarity questions. And thank you.